Hi, this presentation is on domain of radical functions. Domain, the domain of radical function with an even nth root is the numbers for which the radicand is positive or zero. Why is that? So, for instance, if we have square root of x. Now, if x is 2, then square root of 2 is a real number or is real. But square root of negative 2 is imaginary. So that means for a square root to be real, the radicand, which is the expression in the square root, must be positive or 0. 0 is fine because square root of 0 is simply 0. Now, the fourth root of something uh, falls under the same rule because 4 is even. For example, if we have the fourth root of uh, of 16, well, that's 2. But if we have the fourth root of negative 16, well, that's imaginary. It's not real. So it means the negative 16 will not be in the domain of the fourth root of uh, x. Um, so any radical with an even nth root, its domain is the numbers for which the radicand is positive or zero. Is either positive or zero. Let's work on example 4a. Question says find the domain of each function analytically. So we said since this is a square root, then the condition is 7x minus 70 must be either positive or 0. Now we solve this inequality. We add 70 to both sides, or we can divide everything by 70 either way. So adding 70 to both sides and then dividing 70 by 7, which is 10. Now what this is saying 7x minus 70 is positive if x is, 7x minus 70 is positive for 0 if x is greater than or equal to 10. So using interval notation to write the domain of the function f in example A, we can use a number line. It's optional, of course, but we can use it. The 10 somewhere on the number line. Since this is greater than or equal, so it means we include the 10. We can use different color. We can include the 10. And then the greater than, it means everything to the right of 10. So because we're including the 10, then using interval notation, we need to start with bracket. That means we are including 10, and then it extends to positive infinity, and that's parentheses. Those will be the domain of the function in example 4a. We can also work on the function of example b. So again, we want the radicand to be either positive or 0. So we got x squared minus 2x minus 15 must be either positive or 0. We can factor this to solve the inequality. x and x, and these factors to -5 and +3. Alright, we're going to use the number line to solve this inequality because we want to determine where the product of x minus 5 and x plus 3 is positive, also where this product is 0. So when we use number line goes from negative to positive infinity. Now the zeros, there are two of them. We now want x equals -3, x plus 3 will be 0, times x minus 5 will be 0. So we got a 0 when x is -3. Do we include this 0? Yes, because this is greater than or equal to 0. Because of the equal, then we do include it. So we should have a closed circle. And then this is also 0 when x equals 5. Do we include it? Yes. So it must be a closed circle. Now we want to determine where the product is positive and where it is negative. Of course, we consider only the positive because we want this to be greater than 0. So what we're going to do, we're going to choose a value on each of these intervals. The interval from -infinity to -3, and then from -3 to 5, and then from 5 to infinity. So let's choose a number that is smaller than -3. For example, -10. -10 minus 5, that's negative. -10 plus 3, that's negative. And negative times negative, that's positive. So we know that the product on the first interval from -infinity to -3 is positive. Now we can pick, or we can choose a number between -3 and 5, a 0. 0 minus 5 is negative. 0 plus 3 is positive. The product is negative. Let's choose a number from 5 to infinity. Let's say a 10. 10 minus 5, positive. 10 plus 3, positive. The product is positive. Positive times positive is positive. Now we can clearly see where the product of x minus 5 and x plus 3 is positive. It is on this interval, which is from -infinity to -3. It is also from 5 to infinity. And of course, we will be including the zeros as well, which are 2 at -3 and at 5. So the domain would be from -infinity, comma -3, including -3, so we have to use bracket, union bracket 5, because we do include bracket, comma infinity. Now, before we do example 4c, we want to go over the concept first, the concept of the domain of radical function with an odd nth root. So the domain of a radical function with an odd nth root is all real numbers. Well, the reason why I give you a couple of examples. If we take the cube root of 8, that's 2. If we take the cube root of -8, that's -2. It's not imaginary, it's real. It's -2. We take the cube root of 0, that's 0. So cube root of a positive is positive. Cube root of a negative is negative. Cube root of 0 is 0. Same for the fifth root, seventh root, ninth root, 11th root, and so on. For this reason, we know that the cube root or the odd root is real for any number on the number line. If the odd root of positive number is positive, the odd root of a negative number is negative, the odd root of 0 is 0. So now looking at example C, example 3C, because this is the cube root of x minus 4, so there is no work for us to do. We're going to say that the domain is all the real numbers, which is negative infinity to positive infinity. Let's do example D. Example D says m of x equals 9x minus 2 to the power of 3 over 2. If we write this in radical form, like this will be the square root of 9x minus 2 cubed. So it is an even nth root. It's not odd. So we have to make sure that the radicand is positive. 9x minus 2 cubed gotta be either greater than or equal to 0. So if 9x minus 2 is positive, and that's what we want it to be either positive or 0. If it's positive, the cube of a positive is positive. If it's 0, the cube of 0 is 0. So we only need to solve for 9x minus 2. Or you can look at it in a different way. You can take the cube root of both sides. On the left side, it would be 9x minus 2. On the right side, it would be simply 0. That's another way of looking at it. Something like this. So 9x minus 2 cubed greater than or equal to 0. You take the cube root. You take the cube root. It will be 9x minus 2 on this side and a 0 on that side. Now you add the 2 on both sides and you divide by 9. So the square root of 9x minus 2 cubed will be positive for 0 as long as x is greater than or equal to 2 over 9. Interval notation would be, so domain is bracket because we include 2 over 9 comma infinity, and that's the domain of example D. Let's work on example E. So example E, we have two things to worry about. First of all, x plus 2, which is inside the square root, it must be positive or 0. However, so first we can write, okay, it's positive or 0. But the problem is, this time the square root is in the denominator of this function. Therefore, even though the square root of a 0 is defined, or it's real, we still cannot include that because a square root of 0 is 0 and 1 over 0 is undefined. So it means I need to only make sure that x plus 2 is positive. Good. Now solve the inequality. X is greater than negative 2. So the interval notation, okay, let's use the number line quickly. Negative 2 not included. I don't want to include negative 2. So according to the inequality, it's everything greater than negative 2. So the domain would be parenthesis negative 2. I'm using parenthesis to signify that negative 2 is not included. to infinity. To example F, again, example F, we have two things to worry about. First of all, the denominator, x minus 6, has to be different than 0. So x minus 6, we can do okay, not equal to 0. That is true when x is not equal to 6. So we don't want the 6. We want x to be different than 6. And then that's in regards to the denominator. Now in regards to the numerator, the square root of x minus 3 is defined or real as long as x minus 3 is positive or 0. So we solve the inequality. We add the 3 to both sides, and we're done. Now, why are we including 0 here? Because now the radical is in the numerator. It's not in the denominator. So we got two things to worry about. Use a number line. First thing is 6 is not in the domain, or 6 cannot be a value of the domain. And the other thing is x got to be greater than or equal 3. So 3 is somewhere here. We do include it. We do include the 3. We include everything greater than 3. Actually, not everything. Everything except 6. 6 cannot be included. So that means when we write the interval notation for this domain, we start with 3, comma, we do not include 6, so we use parenthesis, but we include everything past 6. Let me do it this way instead, so it'll be more clear. We include everything from 3 up to 6, but we do not include 6, and then everything greater than 6. Okay, because inequality says greater than or equal 3. If this was not part of this function, then we would include the 6. But we don't, because if x equals 6, then we're dividing by 0. Good. So now the domain is not yet complete. We got to put union, parenthesis, 6 comma infinity. And that's the end of this presentation. Thank you for watching.